Hello Earth, welcome to episode 43 of season 2 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. So if you're just tuning in for the first time, I recommend you go check out github.com/autocolon/cell. I'm pasting the link now in the description. We're going to continue where we left off on the last session, which is we had a major breakthrough with this call called do, which implements sequences, which is basically the equivalent of functions in Cell, and that went very well. So we now have a bit of a mess to clean up because things are working, but let's actually outline what we need to do. So we need to clean everything up, and then that means annotate source code of annotate source code of cell.do, respond and cell.do, and then we need to figure out the issue with how we're going to implement sum. So I'm just drinking something here. How do I want to implement plus? Because I was starting to go plus is the addition, right? Like putting the two numbers together. So I actually want to do it in JavaScript. Yeah, I think it's a reasonable implementation to do it in JavaScript. Although I'm not entirely satisfied with how numbers work in JavaScript, but we can deal with that a bit later. For now, I think we just want the plus to basically work. So what I want to be able to do is to have plus as a sort of call. Yeah. So I was just thinking about how I made things work last episode. So I think I'm going to if we look at the annotated source code, it starts with unparsed element. I think this one hasn't been changed. Here we had this thing, we corrected it a few episodes ago. Then we have text to paths. This should be the same, right? Yeah, text to paths. Yeah, that's a big function that took us pretty much the entire first season to write. Yeah, and part of the season 2 to early season 2. I'm making the seasons too long, I think. So we have all of this. So this is a bit unreadable. You know what would make it more readable? This would make it more readable. At least have headers for each function, right? What? I don't know, I just jumped to a tag away. Sometimes I don't understand what my editor is doing. This is the main parsing function. I guess it makes even more sense to do it like that. So at a glance, it's a bit easier to see where things start and stop, right? Start and finish. So We can even list the functions we have not commented, like cell.do. I never did this actually, but it's not a bad idea. Maybe when I'm in a plane I can actually do this stuff. Sorter, I'm sure I will learn stuff from doing this. And then paths to text. Yeah. I used to think that this type of thing was procrastinating, and I no longer believe it, because just want to keep everything sharp and remain completely in understanding of your system. Well, a lot I haven't commented yet. This would be annotated. Annotating the code, in my experience, always finds bugs and improvements on the code, and definitely increases your understanding. Always. It's always worth it. Yet it's difficult. Like I still find myself skipping it. But not today. We're going to do it. Can't believe I didn't even comment cell call. It's pretty striking. I guess it's a relatively simple function, right? That's what they always say. So now takes 3 arguments. Path, it can be path, get, and puts. I wonder in the end if that change we did to cell.respond to work on one path at a time is worth it. And I think so, because it makes it more specific to be working with just one path. So yeah, let's do this. Okay, this function changed completely. We only use get to pass it to functions, but we don't use it anymore here. So let's just do this. If there is no therefore, there's nothing to do, so ignore this path. So we'll just do it like this. You completely rewrote this function. We define 2 variables, each of them with an index. Leftmost at will have the index of the leftmost at. and rightmost at will have the index of the rightmost at. Note we do a bit of trickery. I did here. It's better said actually. This is an interesting piece of code that I did here. And by interesting, I mean I need to explain it to myself. So if we go through the entire path, finding the leftmost at that has a do immediately after it. If we find it, we set rightmost at to the index of that Why do we do this? In effect, what we are doing is considering the most at do as the first thing we want to expand. We want to leave to avoid expanding the definition here. That's going to be the job of cell.do, which we'll call in a few lines. So at least we know the purpose. Is still not very clear. I'm still in the haze, like myself. Three very important variables, all of them paths. The context path is everything to the left of leftmost path. That is everything that's not a reference is our context. The target path is where we are going to set is the so is we're going to set is the common prefix of all the paths we are going to create or update. Think of it as the left part of our assignment. Is everything to the left of rightmost add plus and equal. This is if the target path is foo equals then if the path we are looking at is foo at whatever, then we know that its prefix for setting new paths will be foo equals. Okay. Actually, remember that all the paths we will set are going to be of the shape foo equals. Yeah, that's the target path. Then the value path is everything to the right of rightmost add. This is the right part of our assignment where we are getting the value from. Note we actually remove any equals from it. It allows us to go get the values of calls that, for instance, of calls have been responded already. Under this, this piece is great. Now you might be asking, what happens when a path has two or more adds? How do we deal with these paths if our logic just looks at the rightmost add only? The answer is the following. The rightmost add will get a new path on top of it that has an equal. It is this path that will get the next to last rightmost add expanded. This can happen if all the adds in one path get expanded path by path onto one that has only equals. That's beautiful. I would think that's actually an interesting thought. I had to discover a recursive pattern twice in cell.respond. First, with doing only the rightmost adds one at a time, and then with cell.do in doing the steps of the expansion also one at a time. That's quite interesting. Important detail is context path. Oh yeah, so now this is a bit more interesting. We are going to deal with the case where there's an if at the beginning of value path. We will now discover what the current value that is a list of paths that will have a prefix of target path should be. We first deal with the case. We do so by invoking cell if. To this function we pass the target path where am I removing the last because I'm concatenating an equal, right? Yeah, minus the equal at its end plus at if. So for example, if value path is target path is foo equals, we will pass foo at if. Also pass context path to cell if. Cell if will return a list of paths that we store in current value. Wait, that we had already. Wow. Sorry, I'm sorry, I just annotated it twice. Yeah, my bad. Try to see if this explanation is better. No, the new explanation is better. If there's do after the beginning of value path, this is a sequence definition. We then invoke cell.do and save the paths returned by it in current value. Cell.do will return what should go in the equal path. Actually, I don't need to be concerned with this. I want to see why am I passing so many things to cell.do. I really need them all? Yeah, I need the operation, the definition path, the message. I think the order of the arguments could be a bit nicer, right? Oh, look at that, we don't use the definition path. I'm looking at the definition. Ah, yeah, because I have the definition here. Oh yes, we definitely use it. Definitely. The definition path is only used there. Okay, well, I'm going to make it operation, the definition path, the context path, the get and the put, and then the message is going to be optional. Actually, no, the message should be after the context path. It used to be, I'm swapping context path and the message. Good. Better. Does it still work? Yes. Nice. For the arguments we pass to cell.do, we take care, we pass define text to let it know this is a definition, not an execution. We also pass a modified target path like we did to cell if. It's good that they're very similar, except that it would be something, would be instead foo at do. Also pass a no that will become is a placeholder for something we'll only need when executing call. This is one with the plus, I just want to place over it. Otherwise, if we get now for the interesting bit, if we get no paths, if we get no paths from local to cell yet, there could be a sequence call in the value path. So we are going to figure out if that's the case. This is for later. Imagine that our value path is something like this. It would be at bar 10. Could be something like that, right? Imagine, wait, the value path is this what's after. That bar is a sequence defined elsewhere. It takes a single number as its message. This could be a sequence call. How can we figure it out? Well, imagine that have a path that is bar in this case we may have bar cocktail as a sequence and with pass 5 as its message, or we may have bar as a sequence and with pass cocktail 5 as a message. What we know is that if any of this is a possible call, there has to be a valid point on which to split the left part from the right part. So we are going to find out in this way. Like this. We are going to iterate the value path as many times as there are steps in the value path. Start by getting the value path, chopping off n elements, starting with n as 1, and concatenating add do to that path. We then shall get that path using our context path. If we got something, that means that if we didn't get something, we just keep on trying until the iteration finishes. If we did get something, that means that we found a path where a subset of value path, a prefix, where there's a sequence definition. We will consider that to be our definition path, and consider whatever is to its right in the value path to be the message. This is more intense than I thought, to the annotated source code. And having all those ifs open because the last part of the function is the same, and they annoy me, but if there is indeed a call, a sequence in our value path, we invoke cell.do, passing the definition path, the context path, the message, whatever is to right of definition path inside value path. Cell.do may return a set of paths. Will return a set of paths that we will set on the target path. However, it will also directly set the expansion of target path, but it won't return it. We will cover that when we annotate it. In which case do I need this? I am why do I need this? For the errors, yeah. Expected invalid equal error. The definition of a sequence. Yeah, okay, so it's 1, 2, 3, 4. 1, 2, 3. So it's already 3. Why not 4? Oh, these are better ways to compare it, right? When I return an error, what am I returning here? I know this is part of cell.do. Yeah, this is correct. I just really want to understand this. It annoys me. It's a small detail, but it annoys me. I want to understand it. Why does it get rid of ref? Let's just look at the example. Because reference is a reference to something that has an error. Yeah. It's a reference to a sequence that's improperly defined. That's really cool that we have that. I'm very happy we did that. It's gonna save lives. Well, parts of lives. Definitely my own in the future. But why? What is the target path that I'm slicing? That's what I need to understand. He wasted, so like I'm basically removing stuff from the target path. The current value is just this error, which looks fine. I don't get it. Let's try to get it. Just do it here. What? What do you mean it's not doing it? Am I never executing this anymore? It's completely unnecessary. Oh my god, okay, I didn't understand it because it made no sense. Ah, that's good. That's great. This never runs. Really? Yeah. Yeah, what was I doing there? Honestly, I forgot. It made more sense before, but now it just can be done, right? Ah, yes, thank you. I'm building one line to piss people off. Yes. Okay. By now, we are done. We have a current value. This will allow us to have paths like foo equals, which is more illustrative than correct than foo equals remove the indentations here. Oops. Perfect previous value, and this has served as well, but it's time to lose it. Wow, it's really happening, huh? It's really coming together. Actually, getting rid of the comments is fun. And then I can just reuse this. Do we need to return anything? Why? Ah, that's interesting. So whenever cell.respond does something, we stop. That's good. That's good. I was being smart that day. I guess. I have those days too. What iteration? What iteration, you may ask? Well, cell.put is calling cell.respond on each of the paths of the data space, one at a time. When one of them triggers a call to cell.put, this triggers a call. We don't want the original call, the outermost or the outer call to cell.put, redoing all the work. We'll just leave that to the inner call to cell.put. Returning true is a way to stop the outer loop. And if we don't do it, I believe actually we go into oh no, it still works. I guess it's more inefficient, right? I'll just still leave it. This is only done for efficiency purposes. We need, of course, to have some performance tests when we're more mature. All right, look at that. I think cell.if should go at the top as it was before. I changed it before because I wanted it to be closer in the code so I could debug easier, because I use 70s technology, but now we can restore back the natural order of things. This one I think was happily unchanged. I wrote this function in one session. It worked beautifully. And I'm not even sure if we annotated that day, but it looks exactly as it is. It's such a happy function. Yeah, that's it. Yeah. I want to see how cell did. Have cell get and cell put, which I'm glad we have there. I'm glad we have them annotated because those are heavyweight functions, and we will have to review them because we definitely changed them. At least cell put we changed, I'm sure. At cell do we have nothing. So how are we doing on time? I think we need to stop right now. We're gonna stop, but we made good progress. No logs there, and things are running. We need to, of course, continue, but I think this was a very solid cleanup we did on cell.respond. We annotated the new cell.respond. It's looking really good, except for this sore thumb here. And then we're gonna annotate this beauty here, which is long. It's pretty much 100 lines, although we have a few comments there. So maybe 90 lines, 85, not less than that. It's a heavyweight, but it's doing a lot of work for us. So we need to be grateful. I need to be grateful for it. So yeah, we're gonna annotate this on the next session. Thank you so much for watching. I'll see you next time.